The problem with making electrical circuits is usually tangled wires. You get a mass of these tangled, very long crocodile clip wires, and you can't see what it is you're trying to do, and it's very difficult to relate the circuit to a jumble of wires compared to a nice, neat circuit diagram. So why not make the circuit look like it would do in a properly drawn diagram? So what I've done is I've taken all the basic parts and then I've reduced them in size to keep them in a sort of small person or two-person desktop area, and then brought together a set of components in a box, little suitcase, which can be locked away. So this means the whole thing's really easy to manage. And then if you make a decent set of rules to go with it, guidelines for the children to follow, then things end up nice and tidy at the start of a lesson. It's easy to see what's going on in the circuit because you don't have these long tangled up wires, and everything can go back at the end, and before you close the case you know that all the parts work for next time. So there's nothing worse than bringing out a box which is a jumble of wires, bulbs that you're not sure about, batteries that might be flat. This solves the problem. So it's a basic box, it keeps everything self-contained, and we can start by saying, well look, let's identify all the parts and we'll do them one at a time. So our little crocodile clip wires can be pressed and squeezed like that. Some children haven't used them before, so you've got to go through this. Pressed and squeezed together and then clip back together at the end. So what I usually do is say, right, let's move all of the parts one by one, well, nearly all of the parts one by one, into the box lid, and that creates a working space. So there's a second crocodile clip wire. You can see there's very few components to get it started, but extra ones can be brought in. We've got our little light bulb there. So what I've done here is put these two little machine screws sticking out through it, and the idea is that the crocodiles can very easily clip onto those screws and make an electrical connection. So the actual screws themselves are joined to the connections of the light bulb. So a little light bulb there. Similarly with these screws, I've attached a buzzer, so no long wires to get tangled up, keep them all nice and simple, and then a switch. With the switch, the connections, two little screws there, stick out from underneath. Now I've deliberately made it so that the battery, or cell some people call them, battery, is kept in a certain place and can't move. Later on you can bring in extra cells and be more flexible about where you position things, but just for now there are so many things you can do without the need for moving the cell at all. And I deliberately put two very short connections onto the battery holder connections, the cell holder connections, so that the children can't simply, oh, let's be nice and tidy and we'll clip these together to put them away at the end of the lesson. The worst part about making circuits is like simply guessing what to do. And children will say, oh yeah, if you were to say, let's explore or investigate the circuit, it's a free-for-all for anything connected to anything. And really that's the worst approach you can take to making electrical circuits. So here we've got a way of sort of cutting out the first big mistake, which is short-circuiting a battery directly across itself, so that the current flow doesn't do anything except damage the battery. So we've got to avoid a short circuit. Now I know the children could just take a wire and then link between the two, but at least this means that when the thing's put away in the box, you know that it isn't in contact with anything, and the batteries have got to be working at the end of the lesson and then at the start of the next lesson. So our basic components: cell or battery, electrical wires, some people would say a conductor on the inside, insulator on the outside, so a wire is made of two parts, a plastic or insulating material and a metal conducting material. The metal conducting material is inside the wire, and the only bit you get to use is where it's exposed at the actual crocodile. So we've got our two crocodile wires, we've got our switch, we've got our buzzer, our light bulb wires, end of a lesson, away it goes.